Hello everyone and very good afternoon to one and all. And today's session is again on DBMS, and this is part 8 of DBMS, and we were being learned about the DBMS in the previous sessions. Okay, so I mean to say we have learned a lot of things from the day one started, right? So I mean to say that we have learned about some kind of file systems and drawbacks of the file system, and why the databases are introduced in the market, and why these databases will be most revolutions in the market. And last few days we have been talking about the different rules of EF court. So in that we are been talking about almost actually 12 rules. We have all the 12 rules has to follow by any RDBMS products. So hope you guys know what are the RDBMS products are. Okay, now I'm been looking into the yesterday's session once. Okay, in yesterday's session we are been talking about the relational data models concept. Yes, in the relational data model concept we have been talking about a few important factors there. We are been talking about some kind of records, we have been talking about the tables, we have been talking about the relation instance, we are talking about the relation, all these things. And the major objective of the today's session is we are being learned first a constraints. And I was being explaining you about this constraints yesterday, and let me revise it once again so that will continue this today's session. And yesterday we are being learned about constraints. Constraints are the base concept for every application databases. Why this is most important is constraints is a major part to apply the conditions to any attributes or tables of a particular databases. That is what the major reason why this particular relations has been. Now what is the relations are? Relations are something which whenever you combine the data of a multiple tables, okay, as I am talking about the relations, relation itself will tell you that something has to be related to one to other one. So this will be related to one to another table based on some attributes. I mean to say that I was explaining you in the last day that I have a table in which I have a multiple columns. I mean to say multiple attributes I have, in which one attribute is sequentiated to another attribute. For example, at first table 1, attribute 1, I can able to sequentiate it to another attribute of a second table. Like this, on a single table what you have defined, on that particular table you have a lot of chances to make a relations between multiple tables. So that what it will happen at end of the day is, at end of the day particular thing or end of that particular requirement is you want to get the data from multiple tables. It is pretty simple, you can get it from multiple tables with the help of different attributes which works with the same table or sometimes different tables. Yes, so I am been talking about that right now. Now let me show you what we have learned yesterday and what we are going to learn for today. Now let me show you the slide once. Yes, so we are been talking about the different things in yesterday's session, right? So in which I am been talking about the tables first, and followed by we have been talking about tuples, and followed by we have been talking about relation instance, and we have been talking about relation schemas. This is what we have finished, and today majorly I am going to concentrate on the concept of relation key and followed by attributes domain. And the attribute domain, how does it works, what are the important things which we have. Basic thing I will explain you, first. Right, what is the mean of this domain is? Domain is something, for example, sometime your domain is about integral, sometime is about string, sometime is about floating point. That are the different domains we are basically find, in which we have a depth concept. That is actually the looks concept, looks very good. So when you understand this, you can design your databases very simple. Mean to say that before you start to design any kind of databases in for any real time application. See that guys, I can design the databases for a number of applications in the market, right? You have applications like Facebook, Twitter, Gmail or whatnot, different applications in the market. Before you start working on the application, first as a application developer or a database developer, you have to have a first structure for the database. Nothing but you have to design an ER diagram. According to that ER diagram, you have to convert this ER diagram into a tabular format, so that your data of a DBMS, your data of a database management system, which itself will tell you that your data are going to store in only in tabular format, right? That is what we have discussed yesterday also, right? So today is majorly I am going to talking about the base concept about constraint. Now let me see the screen once again. Today we are been talking about constraint, because actually I need to talk yesterday, but due to time constraint I was not able to talk about this. Today we are going to finish this constraints topic, and we are going to go for the next relational algebras, all these things. Alright. So now the first thing is we will finish it quickly, constraints, because as you have already have explained you a few things from constraint concept, and then we will go to the next part. Now let me first think what actually a constraint is. Yes, what is actually a constraint is? Constraint, there must be at least one minimal subset of an attribute in a relation which can identify the tuples uniquely. Yes, 100% correct. What is a mean to say this one is, I mean to say that, for example, whenever you want to identify any tuple, the moment when I call it as tuple, you guys need to get something in your mind that it is a record. Yes, the record what it will do is record in the sense some kind of rows which presents in your table, right? So that has to be identified uniquely. If that particular row is not identified by unique, what are the different problems you are going to face? You can face a lot of problems. The problem is, instead of getting particular tuple, you may get a 2 tuples, sometimes you may get 10 tuples, because as that particular tuple is not identified uniquely in your table. Unique in the sense, there should be a specific attribute or specific subset of your table which has to have nothing to integrate with another one. I mean to say that, for example, best thing I will tell you. For example, you have number systems, right? Number system 1, 2, 3, 4, 5. If I am going to store the data in that format, there is supposed not to repeat. For example, I have a tuple number 100. The same tuple number 100 supposed to not to repeat for the next time. If it is repeats, what will happen is 100%, and when I am searching for the tuple 100, I can get the 2 tuples. Yes or no? Then is that a perfect thing? Is that a correct thing you are doing? No, you are not doing correct thing. You are doing something wrong with your designing of your database. At that moment, you have to remember that compulsory every record of a particular table, every tuple of a particular table has to have identified by unique, such a way that whenever you reading the data from that table, it would be very easy for you to read it, and it would be very easy to remember the data for the next time. Alright. So now let me show you the second point of this. The minimal subset of an attribute is called a key for the relation. Yes, please remember that point. You will get this point, right? The minimal number of subsets of an attribute is called as a key for the relation. And if there are more than such minimal subsets, those are called it as a candidate case. Yes, very important point you need to remember on this. What is it mean to say? That, for example, if a particular table has to have one attribute which have a relation, so that I can call it as a simple single key. Alright. So the keys I am going to explain you in the next thing when it comes to an implementation part. Don't worry guys, all this particular theoretical points will be implemented for sure in the coming days of time, right? Because this theoretical part which would be very important as you are attending an interviews on any DBMS products. That's the reason. First, you have to analyze the theoretical part. You have to understand the theoretical. If you are able to understand theoretical part, writing the queries or working with the databases, it's pretty simple concept. Now, in the similar way, what I mean to say right now is, I have a table in which I have only one particular subset. I have only one minimal subset as attribute, one particular, you can just say attribute. That attribute you can identify as unique one, nothing but that is something you can call it as key. If the same thing, if the multiple keys are presented in the same table, whenever I want to integrate multiple tables data? Yes or no? For example, I do require a relation between table 2, I do require the relation between table 3, I do require the relation between table 4, in which what I need to do is I need to write a few attributes or the different keys. In that time, your all these keys, call it as composite keys. Composite keys in the sense it is an extension version of keys concept. Keys will be only one, more than one key, we basically call it as candidate key. Now let me show you the screen again. Right, so please note it down these 2 points, what is a constraint and what is a key and what is a candidate key. Alright, there must be at least one minimal subset of an attributes in a relation, then it's supposed to be identified by a unique, that could be a tuple, and this is a minimal subset of an attribute is call it as a key for the relation. And if there are more than one such minimal subsets are presented on the same table, then these are supposed to be call it as a candidate keys, right. In interview they may ask you this question, guys. In the interview they may ask you this question, what is the meaning of candidate key and what is the difference between a key and candidate key? Key is something which has to be a unique attribute of a particular table. If the same unique attributes are repeating for multiple times, more than single time, then I can call it as all supposed to be call it as candidate keys. Very simple answer for these questions. Alright. So when you are attending an interview for this, mostly they ask you this kind of questions because as they are expecting the same relational model databases. Right now in the market everyone is using relational databases, right. For that reason you will find this kind of questions. Alright. Now let me show you the one more thing. What are the different type of constraint and what is it actually a constraint is? Okay. Every relation has some conditions, that is what I was explaining in the last day, alright, that must hold for it to be valid relation, alright, and these conditions are called it as relational integrity constraints. Very important thing. See that as I need every relation have a specific conditions that must hold for it to be done for the valid relation, then these conditions are called it as referential integrity constraints. Yeah, they see that first I have a key constraints. If it is multiple, I can go for domain constraints, and this domain constraints again which have referential integrity constraint. Yes, I will tell you what is actually the meaning of this. For example, when we are been talking about the different constraints, when we are talking about this different constraint, for example, every attribute of a particular table which holds valid condition. What is condition in the sense I do match one attribute of table 1 to table 2 with another attribute. Am I very clear? So that what will happen is these two tables will hold some value. Like that, table 2 have an attribute, table 3 have also an attribute. These two tables have holds one more particular condition. That conditions holded by this, and all of these conditions when you are presenting in a query format. What does mean to say query? Query is simple thing. As you are writing a statements in the programming like C, C++, Java or whatever it is, the same thing you can call it as in a databases, we can call it as a query. So these queries which contain some referential integrities. Referential integrity in the sense that can be constraints about referential integrity constraints. That is what it means to say about the difference. Let me show you the slide again once. You have a constraint and you have a different constraints here. Every relation have some conditions that must hold for to be a specific valid relation, and these relations are something call it as relational integrity constraints, in which you have a key constraints first of all. Yes, you have a key constraint. This key constraints will be validated as a domain constraints, and domain constraints again referred as referential integrity constraints. So that there are the three main integrity constraints, nothing but that is what types of constraint. First is key constraint, second one is domain constraint, third one is referential integrity constraint. We will be talking about one by one first. we will talk about what is key constraint, what we are talking about domain constraint, and the next we talk about a relational constraint. Now let me talk about first key constraint. What is this key constraint is? Key constraints force that in a relation with a key attribute, no two tuples can have identical values for the same attribute. A key attribute cannot hold or cannot have a null values, very important thing, and that is what the second rule of EF chord. What is the second rule of EF chord? If you remember the second rule of EF chord, you need to place this null value, systematic null or systematic treatment for null values. When you specifically talk about null values, you have to follow the second rule of EF chord. Nothing but you have to place these nulls only on the places where it not be utilized for much longer time. Then you can make updates of it. But if you place this null constraint, if you place this null values in a place where you have constraints are presented, then it will not be valid. It will not be call it as valid relations. Yes, right. So now let me show you the slide again. So your key constraints are also call it as entity constraints. Yes, what is the first point you talking about? What is first point? The first point is telling you that you are supposed to not to have a same two tuples, nothing but there are two records you have in a table which supposed to not to have a same key. Yes, if you have a same key, what is going to happen? Whenever you are trying to read when you are trying to read first record, it also give you the second record also. Yes or no? That is what the basic thing. For example, I am going to place 100 record, again I will place 100 record. What will happen is when you try to read the value as 100, you will get the two records, not the single one. Then what will happen is that your valid relation placing? No, you are not placing a valid relation. And the second thing is the key attribute does not have a null values, and then key constraints are also referred as entity constraints. Please note it down these few points, because in an interview they may ask you what is a key constraint is all about. Okay, guys, so clear on this? Right, absolutely, because can I have for example, maybe people will get a doubt that, for example, sir, I have a key constraint in my table, right? I do want to place some null values, I do want to place some kind of duplicate values in it. Does it valid? No, it is not valid. When you supposed to have that null values, then that particular attribute is not call it as a key constraint, and that is not have any entity relationship, or it does not have entity constraints. Make sure that when you are designing your search and database tables, make sure that identify the few columns of a particular table where you need to apply the keys, and after applying the keys you need to follow the specific condition. Yes or no? For example, I was placed some condition on so and so place, so I do not supposed to follow that. For example, I have a attribute which has to take only values which is more than 10,000. Then I have to follow the condition. If not following the condition, it's supposed to be a failure one. Yes, that is what I mean talking about. Please look at the slide again so that you will understand it. Please note it down if it is possible. Alright. Now, second one is domain constraint. Very important constraint is. What is mean to say domain constraint is? Attributes have a specific values in a real world scenarios. For example, age can have a positive number always. The same constraints have been tried to employ on the attributes of a relation, and every attribute is bound have a specific range of values. For example, age cannot be less than 0 and telephone numbers cannot be contained a digit outside 0 to 9. Yes or no? Right. It's very important thing what I mean to talking about right now. Right. So, for example, you have defined a condition on an attribute of the table what you have defined. Yes. On that particular attribute of a table where you define this constraint. For example, if I am talking about Indian mobile number, what does the Indian mobile number does contains the length of the digits or 10, I mean to say the count of digits or 10, in which every digit is something from 0 to 9, not more than that. For example, I want to define the same condition on my attributes. The first digit can be anything from 7 to 9. Yes or no? Right now a mobile number starts from 9, or mobile number starts from 8, or mobile number starts from 7. But rest of the 9 digits has to anything from 0 to 9, not more than that. How a computer knows that? For example, you are doing a registration page, right? In a registration page, they ask you to enter a mobile number which is of 10 digits. How does a computer knows that it has to be only 10 digit? Because the computer doesn't know anything unless or until, as a programmer, as a developer, you have to process the proper input to it. When you are not giving a proper input, when you are not validating an input which is given by the user, then your data is huge. Huge in the sense, instead of giving a 10 digits, people will give a digits of 8. Instead of 8, sometime they will give a 20, sometime they will give a 15. What will happen is your database data is increases all the time. When it is database data is increasing, you have a less scope to store the data for much longer time. In that contains, or in that situations, try to give a particular constraint on the particular attribute of a table. So, I do have an age column, I do have an age attribute on my table, in which only positive numbers are allowed. For example, you are designing a hospital management system, right? Every patient have an age, right? The moment when you enter into a hospital, they will ask you your age. When I enter my age into a computer, when I enter my age into an application, that age supposed to have any negative. If I am giving a negative, what it has to be? It has to give an error message. Yes or no? And age is supposed to not to have a negative values. Yes or no? Same way, when you are designing it, you have to define a conditions, valid conditions, that to be valid condition, valid relation. When you are giving it, so that the person who is using that application, he will also follow the same thing, or she will also follow the same thing. Yes or no? Is it clear, guys? That's the reason domain constraint is a constraint which is applied on the specific condition where it has to be a age is not a negative number, or mobile number is about 10 digits, in which first digit is either 7 to 9, or the rest of the 9 digits or 0 to 9, anything, whatever it is. This kind of things which basically required. Yes, let me show you the slide again. Alright. So, attributes of a specific values in a real world scenario. For example, age can be only positive integer. The same constraints have been tried or to employ on the other attributes of relation. For example, every attribute have been bounded with have a specific range of values. For example, age can't be less than 0, and a telephone number can't be contain a digit outside from 0 to 9. Alright. So, in this particular case, if you are defining any constraints, then we supposed to call it as domain constraint. Domain constraints is again very important factor on your after key constraints. Am I very clear? If possible, note it down. Attributes have a specific values in a real world scenario, compulsory. For example, age is always have a positive integer, and the same constraints if you try to employ it on other attribute of a same relation, you can attribute it if the attribute bounded with a specific range of values. For example, the range of values can be age can't be less than 0 and telephone number can't be a digit outside the. Now, how many constraints you are placing here? Yes, 100%. You are placing a 2 constraints on the same table here. Yes or no? Age is one attribute, mobile number is another attribute, email ID is another attribute. See that sometimes when you enter an email ID always say that username @domain.com. Yes or no? For example, APSSDC @gmail.com. If you trying to enter something more than this, for example, I want to enter something, call it as APSSDC without @ I'll write it as .com. Will it is accept? Obviously, it will not. Why? As a database designer, as a database user or database developer, you have already written a specific constraint over there. Nothing but you have written a constraint, that constraint is employs on the front end user who is using that application, because the application users will not know anything. right? See that, believe it or not, the person who is uneducated, still the person have a Facebook account. How does he knows that? He can create an application. It is pretty simple. The instructions what you are passing on his mobile, on his laptop or a desktop, then he is following the same thing, right? Nothing but you have provided him a specific valid conditions. You have to give a mobile number in the same way. So, he is following the same. Means what? You are constructing a road. On the road, you are making a user to pass it. Yes or no? Pretty simple. Constructing a road is providing a condition and passing the vehicles on it, nothing but using that application. Nothing but I want to place more than one condition on the same table, then it comes under domain attributes. Yes, am I very clear? So, we are been talking about the domains in the next also. Yeah, now let me show you the slide again, and the next one is referential integrity constraints. Alright, so referential integrity constraints work on the concept of foreign keys. Very important thing, please underline this point. Underline this point called foreign keys. What is this foreign keys? Let me talk about right now. Right, a foreign key is a key attributes of relation that has been referred and another relation. Yes, referential integrity constraints states that if a relation refers to have a key attribute of different of same relation, then the key element must exist. Yes, what is mean to say that? For example, now let me give you a simple and real world example. You have a two tables. Table number 1 is user information, table number 2 is contact information, in which I do want to make a relation. Relation nothing but your table 1 is this one, your table 2 is this one. I want to make a relation. If I want to make a relation, I do have a compulsory valid condition for do this two, so that I can make it. Whenever I make this two, in these two tables, some table act as a parent table, another table act as a child table. Nothing but if you do something from a parent table, it will harmful for the child table. But if you do delete from that, from the child table, it will not be effect on the parent table. Yes or no? Pretty simple thing, I will tell you. For example, a father and son. Yes or no? For example, if father have a few properties, right, that will be get deployed to a son also. But son is a process where he can extend it, sometimes he cannot. Even if he extend it, it will not impact on his father. Even he cannot extend it, he will not be any impact on the father. But if his father, sell his properties, sold his properties, then what will happen is obviously that impact on his child. Nothing but, for example, as a parent, okay, my father has a 10 acres land, in which he sold out almost 9 acres. Do I have an impact on me? Obviously, I do have an impact, because in this way I do some changes my parent table, 100% it will be effect on my child table. But if I do some changes in child table, but it will not be affected on the parent table. That is, when you are making a relation, something is said to be a foreign, that whatever it is relation, right, this relation is said to be as a foreign key, right. So, this foreign key will state you that the relations about your parent and child tables, then you will understand very easily when it comes to the implementation part. Alright, am I very clear? Now let me show you the slide again once again, so that we will try to finish off this all integrities. Alright, referential integrity constraints work it on the concept of foreign keys, where the foreign key is a key attributes which is relation that can be referred to another relation, it will be related to another one. Referential integrity constraints states that if the relation refers to a key attributes of it or the same, sometimes you can refer to another table, sometimes you can also refer to the same table, then the key element must supposed to be exist. Nothing but where if I make a relation of multiple tables, how do I do it? There should be a specific key supposed to exist in both tables, then only I can able to make a relation, then only I can make it as a foreign key relation, otherwise I can't. Yes. So, these are the different type of constraints concept which is presented in a database management systems, right. What is the first one is, the first one is key constraint, second one is domain constraint, and the third one is referential constraint. Yes, do clear on this everyone guys? Alright. So, now what is our agenda is, we will learn something in depth of this concept. What is meant to say that algebraic relations, sometime the relations is about, or sometime the relations is of your exactly the status of another table. Mean to say that sometimes I can make a bonding of these two tables based on the tables what other people has given. Yes, alright. So, that is what actually we are talking about, right. Well, that is what I just my agenda is, algebraic, nothing but it is some kind of a mathematical part. So, how does you can make it, how does you read it, how does you post it, how does you minimize the data, and everything is concerned. I mean to say you guys are a bit perfection in mathematics, then it is very efficient, very sufficient for me to work it on the algebraic relations. Here you have to know about a basic mathematics, like how to use a plus operation, minus operation, all these things. Along with this you need to know some less than or greater than operations, and you need to know some union, all this basic operations in algebraic mathematics, right. So, you are being good at all these things, I hope, right. So, I am just talking about relational algebraic on the basis of databases, right. So, I am not talking about mathematically, I am talking about the databases which I am supposed to talk about right now. Alright. Now, let me show you the slide again. It is all about relational algebraic, in which what is the first thing I need to know is what is mean by relation algebra. Alright. So, relational algebra is a procedural query language which takes instance the relations as an input and else instance of the relations as an output. Alright. Second thing is, it uses operators to perform a queries. An operator can be either unary or else sometime binary also. The concept, or they accept the relations as a pair of inputs and the relations as their outputs, right. Relation algebra is performed recursively on the relation, and intermediate results are also considered as a relations. Now, first, before I am talking about all the nonsense, I just want to talk about what is first operator is. Yes, you are been talking about plus, minus, equals, double equals to all this comes under the concept of operators, right. You are been talking about, or you are bit good in this, right. Because as you are, if you are dealing with the programming languages, you are dealing with the databases, these operators plays very vital role in your development process. First, what is an operator is? Operator is a symbols, operator is what? A symbol which performs either arithmetic operations, nothing but unary operations, and it sometimes it also performs logical operation, that mean to say that binary operations. Yes or no? Operator plus, what it performs? It performs addition operator. Now question yourself that have you written any program? See that computer is all about program, right. Computer itself will tell you all about a program, because computer doesn't know anything unless or until if you are giving a proper instruction to it. Even your mobile is also doesn't know anything unless or until if you are giving a proper instruction to it. Yes or no? But if you write C is equals to A plus B, A value is 10, B value is 20, then you get the output value C of 30. How does it is possible? How does it is possible? Have you written any program to a plus sign there? Have you written any sign to plus sign there? Have you written any program to it? Yes, obviously you have not written any program, but the plus sign is always performing an addition sign for you. Why? It is pretty simple, that the operator which can perform either arithmetic or else logical, which assigned by the compiler who has designed that software is. Yes or no? C is a compiler, designed by some ex programmer. He is already written that plus sign is always perform addition operation. If you imagine a database like Oracle or Microsoft SQL Server in which you are having a plus sign, what it mean to say that this plus sign is also will tell you that this plus sign is always has to perform addition sign. As a user, what we are using is we are just putting a sign or we are just putting a symbol on the application when you are developing it, but operator is performing this. Yes or no? Yes. So that's the reason you can conclude simply operator is a symbol which performs either arithmetic or assignment or arithmetic or a logical operation given by or assigned by the compiler who is designed it basically. Now this will takes the input from the user. First of all, any operator takes the input from the user, whether it may be a constant value, sometime it can be a random value, takes the input from the user and perform its operation on the background, and then it gives you an output. That is what I am been talking about in the relational algebra also. See that once again the slide. Relation algebra is a procedural query language which takes the instance of relations as an input, takes the input as a input format and performing its own operation, and at the end instance of output it provides you as a user. It uses operators to perform a queries. A operator can be either unary or binary, that is what I am been talking about. They accept relations as their input and the relations as their output, nothing but it takes the input, gives you output. Algebraic relation is performed recursively on the relations and intermediate results is also accepted, nothing but sometime there are a few operators, there are a few statements, there are a few queries in your databases or in your front end. Sometimes your middle or your I mean to say that, for example, or okay, I'm writing a statement in the I'm writing a statement in a programming. So what it mean to say that, for example, I have been completed a half part of arithmetic operator. At the time I can give that value, I can take that value also, right. For example, I will write it as C is equals to some A plus B comma something other value. So what will happen is at the time of addition it will be addition it takes the intermediate value, it stores in the intermediate value, and sometimes it can also assign it. That is also be considered. Your relational algebra, that is also intermediate value is also considered, medial value also can be considered, right. So what is actually you are being learned in this part? Let me show you the slide again. The fundamental operations of algebra, right. What is the fundamentals of algebra is, these are 6 points. Please note it down. What is the 6 points? Or select, project, union, set different, Cartesian product and rename. Hope you are some people if you are good in mathematics, not like me because I am not good in mathematics that much, alright. So in that if you guys are a bit good in your mathematics, so you are already learned about all these things, right, union all, Cartesian, product, select and all these things, right. The same concept will be utilized in your databases also, nothing more than that. If you need to have a small idea, as a theoretically you have to get an idea, so that when it comes to implementation part I will show you how it works, right. Let me show you the slide again once, right. So how many points here? 6 points. We will learn these 6 points today if possible, otherwise we will go for tomorrow's session, alright. So the first one is a select operation. Select operation will be it select the tuples that specify the given predict or sometime can be a select statement relation from the particular relation what you have given. I mean to say that this selection operation, what it will do is this selection operation will not be any changes. For example, you are writing any select operation for a particular table, then it will never changes the data which is presented over there. What it will do is it is trying to predict what is presented over there and just give you the result. Yes or no? For example, For example, today I was been into this class, right? Now, if I am applying a select statement, what it will happen is it just show you how many students are right now online, right? But this select statement will not add a new person into this class, yes or no? If someone is adding, that is not selects part, that is some other part, yes or no? But when I am predicting my output from my end, then I can write it as some select operation. What is the selection operation will do is, selection operation is to get some values from your databases which never affects you on your database information. Yeah, now let me show you the slide again. Here the sign, here that something selection operation sign is predict, and R stands for relation, P stands for preposition of logical formula which may connects like or, and, not, and these are sometimes or a relational operators like less than, greater than, less than or equals to, greater than or equals to, not equals to, all these things. Am I very clear? See that, mean to say that this one, the symbol whatever I am showing here, right, this symbol which shows you something, call it as selection predict, selection predicate, whatever you can call it as, that doesn't matter, alright. So this one which tells you either of this, what will happen is and or not, which always return you a binary value, nothing but either true or false. And the other operations like relational operators like less than, greater than, sometime, not equals to, all these things, alright. So that all comes under selection operation. For example, if I am writing a subject, I want to get the database, something call it as books. What will happen is, what is the output you will get? It select the tuples from the books where subject is the database. Understood now? See that, you mean to say that books is a table name, books is a table name. In books table, I do have a number of tuples, but I do not want to get all the tuples here. I do want to get a tuples whose a particular subject is database, nothing but I do have a subject like programming languages, databases, English, communication skills, or whatnot, information technology, whatnot, different subjects I have, in which I am selecting only a subject of databases. And is this database subject is presented, it shows me a records or it shows me a tuples. If not, it does not shows you anything, simple as that. Alright, now let me show the slide again, one more example I was given you there. Tuple subject, the records either database, first thing is, first condition I am writing and, nothing but condition I am trying to place here, and the price is about 450 from the table called books. What it will returns you right now is, it is, I mean to say you are, okay, best example I will tell you now, best example I will tell you, you are going to purchase some products through online, right, like Flipkart, Amazon or eBay or not. On the selection of particular category, the left side it will show you some operations like the price is between 199 to 499, alright. Second one is 599 to some other. So if you do select that, what will happen is only that particular products will be displayed, and the next it will show you something called t-shirts, jeans and all. If I select t-shirts, what will happen is only t-shirts it will show you, nothing but what will do is it is trying to segregate or it is trying to decreasing the data which is presented in my databases. How does it is possible? The practical is this one, right, just show the slide again. Alright, you have a database in the sense some subject name, and the price has to be on 450 rupees. So that what will happen is, the select the tuples from the books where your subject is database and the price is 450 years. Understood? This is how you get the data from the different tables. For this you need to write some language query, you will write a query there so that it will be reflected on the databases. As soon as it will be hits on the databases, as soon as a query hits on the database, it's come up with the result is. Yes, so we do discuss about it in future because it's again 2-3 days time, still we have some theoretical part. Once it is done, I'm going to show you all this theoretical part with a practical implementation, what you are showing, what you are seeing in a practical or real time scenarios is. Alright, right, I guess it's a timer for the day. Alright, so thank you so much for listening. Have a great day. If someone needs or some of your friends needs about your databases concept, data management systems, you can try to share with this share these videos with those people, so that you will be a person who can help to your friends. Alright. Thank you so much for listening. Have a great day. By the way, I am Anil Kumar, the trainer of APSSDC.